Okay, now we will learn how we can find the how we can find an element in an array. So here we are taking searching program. So we will do a linear search in an array. Suppose I am having 5 elements or 6. Suppose this is 17, 18, 2, 3, 4 and 5. So suppose I need to find a particular value, whether it is present in an array or not. So to find a particular value, here I am taking a data structure array. So here I will write a program. So obviously we are doing analysis of our algorithm. So we have to find the time complexity of a program that we will write. So here I will again write a program of searching a number, then I will analyze that program. Algorithm is basically a steps. So whatever steps we are writing in a program, that are the base of algorithm. So that I can write in the form of steps also. So here I'm considering a program that is used to search a particular value in this array. So suppose my array is an integer array. So here in my array, how many elements are there? These 5. So I'm writing like this. So I need here number of elements is equal to 4, 5, 6. Right? My n is 6. So I'm writing here int n equals to 6. So here what I need to do is I have to make a loop which should run from 0 to 5. This is 0 position 1, 2, 3, 4, 5. That you know that the array position starts from 0 location. So this is my A0 element, this is my A1 element, so on. This is my 5 element, right? It's because we start from 0, so this will become 5. So I have to make the loop go from 0 to 5 and find a particular value inside an array. Suppose what I want to search, here I am changing it to comma. Here I want to search an item. Suppose I am searching for 4, right? So my loop will go from int I equals to 0, I less than equal to, tell me, less than equal to n minus 1, because 0 to n minus 1 will become n. Obviously when 0 is coming, so my loop will go from 0 to n minus 1, and I will check if a of I is equal to item, then printf found. Simple, right? So here I have closed my for, and here after that I have closed my main. So this is complete now. So what I need to do, I have to find the time complexity of running such program, because it is performing linear search. Remember, here I am taking an example of linear search. So here how I can find, so here I have to see here that how many cases can it be. Suppose what will happen when I will search for 17, right? One more thing I need to write here, if I found that element I will stop the loop. So here I will insert one more statement, that is break. So here a very simple analysis that you can do, see here, if my number is here, take the extreme cases, because I have to take the best case, worst case and average case. So here what will be the best? Best will be that I'm searching for something and it has been found at the first location, that will be the best. And worst will be that I am searching for something and it is found at the last position. ठीक है, तो अगर मुझे स्टार्टिंग में मिल जाता है that means that is my best case, and if I find it at the last then it is my worst case, and if I find it in the middle then it is my average case, right? So if I search for 17, then how many times this loop will run? Only one times, because at the 0 location I will check here a0 is equal to item, it will be matched and it will stop the loop. So how many times the loop will run? Only once. So simultaneously I can write here that if I see here in the case of best case, in the best case the case is I'm searching for 17. So how many times the loop will run? Loop will run only one time. So complexity will become O of 1, because best case says that it is found at first location, right? So in this array the best case will be when we are taking the 17th value, the value found at first location, that is our best case. So I have to mention here the best case will be not the 17th value, it is basically the value found at first location. So if I find the value at the first location, that will be my best case, right? Now we will move up. Now what will be the worst case? The worst case will be the value found at last position. So how many comparisons will be there? Suppose you match with 0 value, then 1 value, then 2, but at n minus 1 you will find the value. So how many times your loop has run from 0 to n minus 1? That means total n times. So worst case is value at last position, right? So if my value is at last position, that is my worst case. So in that case the complexity will be number of comparisons or number of times loop has run. Loop has run how many times? N times. So complexity will become O n, right? So in my average case, what will be the scenario in the average case? That I find the value in the mid. So if I find the value at mid, that is my average case. So in this case my number of comparisons or number of times the loop will run, number of times loop run is n by 2. So the complexity will become O of n by 2, right? So this is a scenario, this is the complexity at the 3 cases. One is your worst case, the other is your average case, the another is your best case. So these things you have to keep it in mind while you are doing the understanding your algorithm and finding whether it is better or not, right? So consider these complexities in each and every program. Okay, so we have understood in linear search program what is the complexity in the best, worst and average case, right?